Hello, my name is Kyra Williams, and today I'll be presenting Space, Time, and Choice, a unified approach to flexible personal scheduling. With our personal lives becoming increasingly busier and filled with more spatio-temporal restraints, the authors present a user-friendly, unified approach to support flexible personal scheduling. With a single coherent workflow, users can manipulate a multitude of space-time parameters and explore itineraries that satisfy or optimize the resulting constraints. The approach is demonstrated through a mobile app mockup that allows exploration of connected tasks and multi-stop route planning. Motivations for this work are to introduce a spatiotemporal approach to flexible personal scheduling, to support spatiotemporal reasoning, to enable workflow flexibility, to minimize busy work, and to maintain user agency. A proposed solution for this work is the Space-Time Planner. The authors would design and implement a single interface that combines a map and a planner for space-time planning. The system would get desired times and destinations from the user, consider and factor in any requirements, restrictions, and constraints, compute and display possible itineraries, and allow the user to make any edits if necessary. The process starts with the user's motives, which then get labeled as requirements. The requirements are then met with externally defined restraints, referred to as restrictions. The sum of the requirements and restrictions results in constraints, which are output into the user's schedule. Let's consider this example. I want to commute to my class by 10 a.m., meet a friend for lunch, and go to my professor's office hours at 1 p.m. My user-defined requirements would be my commute to class, where I want to arrive by 10 a.m., my class, which lasts 1 hour and 15 minutes, and lunch, where we've allotted 1 hour. Then I want to arrive at my professor's office hours by 1 p.m. Some externally defined restraints or restrictions could be hours of operations for the restaurant, travel time to and from the restaurant, and my professor's office hours. In our example, my class has fully fixed spatial and temporal requirements, where my commute there only has fixed spatial requirements and requires me to be a little flexible in my temporal reasoning. Getting lunch requires me to be flexible in my spatial reasoning because there are several places I could meet up with my friend during my allotted time. My professor's office hours are also fully fixed in spatial and temporal requirements. With the restraints now calculated, one of three things can happen: an under-constrained set of schedules, an over-constrained lack of schedule, or a single solution. One approach to solving this could be to let the system prioritize or relax certain criteria autonomously, or allow the user to reevaluate their motives, consider preferences and trade-offs, or to recreate their requirements. This could prove to be an iterative process, so a hybrid approach may be the most optimal solution. In my example, when I'm ready to meet up with my friend for lunch, there are several places we could meet up. I can put our top choices in a one-of group and the system will choose the one with the least travel time. I could also compare them all at once in the workflow to see which option I may want to choose. Users planning events such as vacation, tours, or festivals can use the as many of groups to pack their itineraries with as many choices that can be fit in the allotted time frame with the least travel time possible. In evaluating the proposed solution, the authors conducted a study with 12 participants who were asked to complete two tasks: T1, a structured task, and T2, a free-form task. The study found that the users were able to complete both tasks in a matter of minutes. In the post-study survey of the responses to "I think I would like to use this system in my own life," 5 participants strongly agreed and 7 agreed. As for my personal analysis, after evaluating the work, I found the idea to be rather forward-thinking. The Spacetime Planner appears to be well thought out and well designed with efficiency and the user in mind. The problem addressed is very real and prominent in society, and this work could be of use to most everyone around the world. A foreseeable issue is maintaining accurate information, such as operating businesses in the area, hours of operations for those businesses, event schedules such as film or music festivals, and traffic updates, etc. In the future, a longitudinal study should be conducted so that participants can utilize the app in their daily lives. This would allow users to test the app fully, notice any bugs or crashes, and to make suggestions. This would also give the authors an opportunity to obtain data on usage rates, accuracy of the suggested itineraries, and more. In the future, the route mapping and schedule planning features could be further optimized by ensuring more precise estimates of things such as hours of operations for businesses, traffic updates, and event schedules. After reviewing the work, the questions I'm left with are: how long would it take until a beta version could be released or tested? What methods or technologies could be implemented to ensure precision planning? Would the app use Google Maps as the default or only integration, or would users have a choice in which map service they prefer, such as Apple Maps, Waze, MapQuest, etc.? The same two questions can be applied to the calendar aspect. Would Google Calendar be the default or only integration, or would users have a choice in which calendar service they prefer, such as Apple Calendar, Outlook, Nextcloud, etc.? Conclusively, I find this work to be very solid, well-planned, and well-executed from ideation to proof of concept. Space-time planning is, in my opinion, the future of flexible personal scheduling and a very viable option compared to planning one's day manually and separately through agendas and a third-party mapping service. The authors found that their proof of concept mobile app was user-friendly and easy to learn. The authors also found that their work is capable of solving the problems presented.